Hey everyone, this is Megan again from OnlineMathCircle AIME video tutorials, and today we are going to look at 2009 AIME I, problem number 7. The sequence a sub n satisfies a sub 1 equal to 1, and 5 to the power of the quantity a sub n plus 1 minus a sub n minus 1 equals 1 over n plus 2/3 for n greater than or equal to 1. Let k be the least integer greater than 1 for which a sub k is an integer. Find k. First of all, what we would like to do at first is to get an explicit formula for a sub n. And what that basically means is expressing a sub n in terms of n, so that we can find easy ways to calculate larger and further values for a sub n. First of all, let's look at this equation here. We can definitely simplify and break this down so that we can find the value of a sub n plus 1 minus a sub n in terms of n. So in order to do this, let's start off by simplifying the fraction on the right-hand side. And by doing so, we get the following. Alright, so the right-hand side turns into 3 over 3n plus 2. Then we can add 1 to both sides. And with 1 on the right-hand side, we get the new fraction, 3n plus 5 all over 3n plus 2. Now we can take log base 5 of both sides, and we get a sub n plus 1 minus a sub n equal to log base 5 of the quantity 3n plus 5 all over 3n plus 2. And by the quotient to difference rule of logarithms, we have the right-hand side equal to log base 5 of 3n plus 5 minus log base 5 of 3n plus 2. Now we would like to find our explicit formula for a sub n. Let's start off by computing several values of a sub n plus 1 minus a sub n for the first few positive integer values of n. That way we can form a telescoping sum. And a telescoping sum is basically just a sum where if you add multiple terms of it, you'll see terms in the middle that cancel each other out, leaving us with a fewer number of terms than there were at the start. And you'll see how this works. So let n equal 1. And when we do so, we have a2 minus a1 equal to log base 5 of 8 minus log base 5 of 5. If n is equal to 2, a sub 3 minus a sub 2 is equal to log base 5 of 11 minus log base 5 of 8. For n equal to 3, a sub 4 minus a sub 3 is equal to log base 5 of 14 minus log base 5 of 11. For n equal to 4, a sub 5 minus a sub 4 is equal to log base 5 of 17 minus log base 5 of 14. And continuing on, we know that a sub n plus 1 minus a sub n is equal to log base 5 of 3n plus 5 minus log base 5 of 3n plus 2. Adding all of these quantities up, we see that the terms in the middle all cancel out each other. So that means on the left-hand side, we're only left with a sub n plus 1 minus a sub 1. And then on the right-hand side, we're only left with log base 5 of 3n plus 5 minus log base 5 of 5. Looking back at the original problem statement, we see that a sub 1 is equal to 1. So we can simplify this equation even further. And then we can get rid of the minus 1's, and that leaves us with a sub n plus 1 equal to log base 5 of 3n plus 5. Well, we look here and we wonder, what if we want a sub n? Well, we can look at the right-hand side and notice that we can write it as log base 5 of the quantity 3 times n plus 1 plus 2. And seeing the n plus 1 here corresponds to the n plus 1 here, this gives us the fact that a sub n is equal to log base 5 of 3n plus 2. So finally, we have an explicit formula for a sub n. Now, the original problem statement says to find k, the least integer greater than 1 for which a sub k is an integer. And basically, we see that a sub n equal to log base 5 of 3n plus 2 is an integer only when 3n plus 2 is a positive integer power of 5. And the least positive integer power of 5 that is greater than 1 of the form 3k plus 2 would just be 125, or 5 cubed. And with 3k plus 2 equal to 125, we have 3k equal to 123, giving us k equal to 41, which yields our final answer.